In this episode, we're going to talk about digital to analog converters. A digital to analog converter, or a DAC, is a device that converts digital information to an analog signal. There are several types of digital to analog converters, but they can be grouped based on the resolution, data interface, supply voltage, and more. Today, digital to analog converters are being used in applications such as audio processors, video encoder systems, sensor calibration, PC peripherals, data acquisition systems, and more. Now, to demonstrate how a digital to analog converter works, I have the MCP4725 digital to analog converter from Microchip mounted on a breakout board made by Adafruit. The MCP4725 has 12-bit resolution with EEPROM memory where we can program the input and configuration data. It has a serial data interface that uses I2C protocol. To program the MCP4725, we interface using the Adafruit Metro through the I2C bus. Since the MCP4725 operates from 2.7 to 5.5 volts, we can just use the onboard 5-volt power supply of the Adafruit Metro to power it up. The A0 pin of the MCP4725 allows us to change the I2C address, but the breakout board designed by Adafruit by default pulls the A0 pin low through a 10K resistor. So we'll just leave it like that and we'll use the default address. We then connect V-out to the oscilloscope to see the output. To easily evaluate the MCP4725 digital to analog converter, we will use a triangle wave sketch provided by Adafruit. The code initializes the serial and I2C ports first, then it executes for loops that run through the full 12-bit scale to generate a triangle wave. Let's upload the code and see the output on the oscilloscope. As you can see, a triangle wave is being generated. There are lots of applications for digital to analog converters. We can always experiment by using devices like the MCP4725 and the Adafruit Metro, or use other devices that would meet the project's requirements. I hope you enjoyed this video from Digi-Key. Thanks for watching.